Welcome friends. Today we will be learning about Anova. Anova is a technique of test of significance which helps us to compare mean across more than two groups. So if we want to compare population mean across more than two samples, then we go to Anova. So let us first look at some theory related to Anova, and for that we have a word file here, and this word file actually gives you about Anova introduction and the assumptions of Anova. So these are the assumptions of Anova, that the observations are independent of each other. The parent population from which the observations are taken is normally distributed, and the treatment and environmental effects are additive in nature. Now we actually look into one-way analysis of variance. Here, there we have k groups, 1, 2, 3, 4, up to k groups, and we have several observations under each of the group, under group 1, group 2, group k, like this. And so accordingly we have this. You see, these groups may have equal number of observations. The number of observations may be unequal also. So all possibilities are there. That's why instead of writing n1 n, in all the cases we are writing n1 in the first group, n2 in the second group, n I in the ith group, and so on. That means these observations under each of the groups may be equal, may not be equal. So these are the means across the groups. This is the mean of the first group, this is the mean of the second group, and so on. These are all sample means. Now based on these sample means, we are to draw the hypothesis that whether the group means, population means are equal or not, whether all of them are equal or not. So that is the purpose of one-way Anova. So this is the famous Anova table, and these are the computational details of the Anova table, which we have already studied in theory. Now let us go directly to a problem. So there are four companies which are making electric bulbs, say maybe CFL bulbs or LED bulbs, and this is the time for which they actually can give the light in hours, measured in terms of hours. So these are the four companies, C1, C2, C3, C4, and we have taken 5 bulbs from each of the companies, and we lead them till they went out of power. So this is the time for which they were illuminated. After that they got fused, they did not work anymore. So I want to find out whether the average lifetime of the bulbs coming from the 4 different companies are equal or not. So that is the purpose. So let us see how we can implement this in R. So let us go to R and do this. Oh, okay, fine. So we come over here to R, and we want to compare the lifetime of bulbs coming from 4 different companies. So obviously at the very outset we like to feed the data. So I give the name, say I give the name maybe C1 is the first company, as it is given in the question as well. And now I input the data, and when I want to put multiple observations, then I have to use the command C command for that. So I type in the values, and so it looks like this. So here I get the value of the first company. Similarly, if you have the data, you can actually, if you have written the command somewhere else, then you can just copy and paste. For example, I have written in Word. To save time, I can copy and paste it here one by one, and then I can have this one also, and I can have simultaneously, I can write the commands as well by copying and pasting. But here I am going with one by one, writing these commands. So, and we have the last one as well. So these 4 data sets, they have come over together. You can use a data frame command. Also you can write the data in a CSV format and call it in R. So there are different ways in which you can call the data set R, but here we are using just the base package and typing it as it is on R. Now what happens first, in order to compare, though it is not mandatory, but this is a good practice, that we draw a box plot, because box plot will help us to understand the variation and also understand the mean of the 3 companies so far as their lifetime is concerned, lifetime of the bulbs are concerned. So we click here, we get the box plot, and this box plot gives us a very nice figure. You see, this red line is the median lifetime of the companies, and it is clear that they are almost similar, A, B, C, that is company 1, 2 and 3, but company 4, it is having much lower lifetime than others. This might be a point of concern. Anyway, so let us look at this now. We first, in order to uh, perform the ANOVA, first we combine the data set into one data set and to a data frame. So what we use, we give a name, say we give a name, we come back here and we give a name, COMBINE, combine underscore group. Now this is a name. You can give some other name also, like you may give CG name or only combine. So all things are possible, and we give the data frame command, and we give the cbind command. That means column binding into a data frame, and that is C1, C2, C3, C4. Now, one thing you have to remember that these company names are given by C1, C2, C3, C4. These are all capital letters. So here I have to retain capital letters. So what I have done, all these 4 data sets, I have combined with using the cbind command and placed it in a data frame and given it a name, combined group. So this is the name, combined group, and here I have done some activity. So I press enter, and since the cursor comes back once again, so it gives me an indication that I am doing a good work, and it is good enough. Now, to arrange the data for ANOVA in R, we use this stack group. And what is stack group? Stack group, this is also name, and it is a stack command. The stack command actually helps to get the data frame ready for ANOVA. So stack group, which one? Combined group. So combined group is the name of it's a name where I have placed this data frame. So stack equal to this is combined group. So I use stack group equal to stack combined group. This helps to get the data combined in the form of an. So once this is done, now my data set is ready for analysis in Anova. So some extra commands are there for this case, unlike from what we have seen earlier. Now what we do is that we actually save the model. We give a name, say we give a name M, and or we give a name, say FM. So this is a model where we are going to see this. But what is the stack group looks like? So let us have a look. Stack group. So let us have a look how stack group is looking like. So you see it has been arranged in this way. So that is the purpose. What is the combined group? What combined group has done and what stack group has done? Let me see. Let me have a combined group. Okay, combined group. Let me delete all these things. I have only combined group. This will show me the combined group. Now you see combined group, the data comes in this way. So this is what combined group has done. But when you give the stack group command, it actually arranges in this way. You see C1, C2, C3, C1, 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 C1 comes in column. Earlier it was in column form, but the observations were in the form of row. Now everything comes in the column form. C1, all C1s together, then all C2, then all C3, all C4. Now when we call the data set for ANOVA, we require the data to be arranged in this way, not in this tabular form. That's why we first combine them and then we have stacked them. So that thing you have to do. Otherwise, from this data set, we cannot directly take the stack command. So we have to first combine them in this form, and then stack it in this form. And that's why we are using these 2 commands at tandem to get the data arranged for the form of ANOVA. So at this stage, let me clear my screen. And then we have this screen, and then we have, we give a name FM, and there we are actually using the result of ANOVA. So AOV is ANOVA. This is the ANOVA command. ANOVA command for what data? We write values called IND. That means the categories are independent of each other, and data is stored in stack group. So stack underscore group, that is the name of the place where you have arranged the data in ANOVA form and you have given this. So let us have a look at the command that we have written. AFM equal to AOB stands for ANOVA. Values are independent of each other and data equal to stack group. So this is done. Now I press enter. So ANOVA, okay, I think there is some Stack group. I think there is some error. Stack STAKE. There is a spelling mistake. Okay, never mind. So I'll have it back. This one STAKE. Okay, so with this, the data set Anova has been computed and stored in A. There is no error command. That means things are going on fine. Now I want ultimate the Anova results, or I want the Anova results because Anova calculations are done and stored in FM. So what I'll write? Anova, then bracket FM. Now when I write this Anova and FM, this system will display the results of the Anova. So you see here what happens, that Anova, how DF for these groups are 3 because there are 4 companies. So 4 minus 1, that is the 3 degrees of freedom, and this value is 0.02. That means they are telling that yes, we have performed the Anova, and the Anova is telling that the group averages are statistically insignificant. Means they are, statistically significant. There is a significant difference among the group averages. And if you look at the box plot, then you understand the story, that this company is significantly poor performer compared to these 3 companies. That means this is a poor performer. So in your organization, if you want to purchase the electric bulbs or say this LED bulbs from the 4 companies, so you may prefer C1, C2, C3. They are almost at par, but you shall not go with C4 because this will put a loss in your company because it has much less lifetime. So this is how we do the Anova for this particular one-way Anova. So this is how we have done one-way Anova. Now let us take an example, extend this example little bit, and we have. Do you have any questions related to this?
Sir.
Yes.
Sir, in last 2 commands, you use FM equal to AOV. And the last one, Anova equal to Anova above of FFM. So what is the difference between AOV and
this is not F of M. This is name. FM is name. You may give any name. You may give any name, like suppose here I give the command, you see. Here I may give the name M also. No problem with this. M also. This is just a name. AOV command is Anova.
Sir, AOV and Anova, sir.
Yeah. AOV is a command which does all the computations of Anova. So all the computations of Anova are done and stored under M. And if you write now, because for this you have to, this AOV command requires the details of whether the groups are independent of each other, where is the data stored, all these things required by Anova command. Anova command individually will not produce this table. To get this table, we have to do the Anova command. You may try it. For example, suppose you want to check, okay, let me see what Anova command gives me. So AOV command, you have written this, okay, fine. Now press enter. You see it comes with degrees of freedoms comes, sum of squares it comes, but it does not give the Anova table. Computation is done, that's fine, but Anova table is not displayed. So in order to get the display of the Anova table, you have to use this command. What? Now you have not stored the data anywhere, stored this command anywhere. So what you have to do is that you have to write this, then you have to write Anova, ANOVA, then close the bracket, and then here this side also you close the bracket. This side also close the bracket. Now this makes the command, okay. Now you see you get the Anova table. Anova table you get. So I can write in this way also. But what happens this way, the command becomes very big. So for that purpose, I have first written the AOV command, which actually do the computation but stores it in FM. And then I use the Anova command over FM to get this table. It is something like this, that you have recruited 2 persons for your home for cooking. Now one is a very good cook. He can cook very quickly, he can cook all different dishes, but he cannot present it properly. So for that you have recruited another employee. Now when the biryani is cooked, that person can cook nice biryani, tasty biryani, but he cannot present it. What happens, the other person whom you have recruited, he will present the biryani very nicely in a plate and put before you. So that is the command. This AOB is the cook and Anova command is the presenter. So AOB does the computation, but AOV will only present the thing before you in this way, which is incomplete. You cannot take any decision from here. So for taking a decision, you require the Anova table. So Anova table will be given by the Anova command. Is it clear?
Yes, sir. Thank you, sir.
Okay, now we control the screen. We have another data set similarly only, but a little bit different in the sense that there are unequal number of this observations. That is more general actually. That is specific that you get equal number of observations in an one-way ANOVA. In an one-way ANOVA, there are unequal number of observations. So your observations look like this. So in that case, I want to type in the data. It is better actually if you type this type of data, unequal number of data in Excel, and then call it. But then I think we have another way of dealing with this. Now let us see how we can perform ANOVA for multiple number of single observation per cell, but when they are unequal number of observations. For doing this, though we can actually type in the data and do the computation, but these things becomes very cumbersome. So first what we do is that we go to an Excel file and we type in the data, and we see that the data is paged in two columns only. In one column we write the lifetime of the bulbs, that is the basic data set, and another one we write the corresponding company from which the data comes. So ultimately you can space your data in two columns instead of using many columns and rows as the original data set looks like. So not like this, but we do it in this way. Now once we do this, then we save the file in CSV format, and we save it as save as, and then we go to documents or my documents, and Anova oneway.csv, that file we save here. You can save in any other folder also, but the thing is that in that case it will be not the default location of R, and so you have to write the entire path. So in order to save this time of typing in everything, I generally prefer to save the CSV file on which I want to work in my documents or documents folder of my computer. Now we come back to R, and we have a clear console today, and so let us start calling the data. So first we write df. This means data frame. You may give some other name also. So read CSV, you know this command, read CSV, and then bracket, and then in the inverted quotes we give ANOVA one way dot CSV, Anova CSV. So this is Anova one way CSV, then header equal to true. So once we give this, now the data is taken, accepted by Anova, accepted by the R console, and then we use the attach command. You know this attach command is very important, otherwise that it works entirely as a data frame. So now attach command helps us to take the data under different variables. And now if you remember this Excel file, let me have a view also. In the Excel file, one variable name is life, another variable's name is company. So just we use this command and we get this. So first let us have a simple box plot to see what is the changes. So how the things are shaping up. So we have a box plot, and then we have life classified by companies. So you have to get the spelling of or the style of writing of your variables correctly. So this will actually generate a box plot. Here you see company 1, company 2, company 3, company 4. This has come up. This is your box plot, and you see company 4 is not doing nicely. It is doing rather poorly. So data is being accepted. Now we use the AOV command. So we store the result in a command called Anova, and we get the AOV command, and then this is the variable is life, and it is been classified by company. So you see these things makes life very simple. So everything is computed and stored under Anova. Now you want the Anova. Okay, fine. You got summary, and then ANOVA. So when you write summary Anova, then it will give you the details of all this along with the table. So we get the table. and we get this is significant. That means there is significant difference. So this is how we actually, with a very few commands, we can handle a complicated data set, which you have seen earlier, by typing it in Excel and saving it as a CSV file in my documents folder. So you see, just this first command is important, second command is important, third command is optional. If you don't want to see the box plot, then okay, fine, no need to see the box plot. And then this an AOV command and then summary command. So basically 4 commands will help you to get the result of Anova. Third one you may drop, but third one brings beauty to your plot. You can use the other accessories like title, x-axis title, y-axis title, etc. You can use in the boxplot command. As we have seen earlier, you can use different types of color also, as we have seen earlier when we studied boxplot in details. This is the basic boxplot. Okay. Now, is this clear till this stage? Any doubt?
No, sir.
Okay.
Sir, can we, sir, instead of summary, we can also write Anova function, right? Yes.
Yeah, we can write Anova function. Anova function we can write. But in that case, I can write this function Anova, ANOVA, and then ANOVA, because ANOVA, capital ANOVA is the place where we have stored the result of AOV. And now I give the Anova command, and we can get this. So accordingly, we press enter, then we get the same result. Yeah. Only here it is written analysis of variance table. Here it is not written analysis of variance table. So that's all. So what is the purpose? Basic thing, you get it here. So this way you can experiment and see what all questions come to your mind. You can do these computations, try different options and check it out what actually is happening. Okay. Now let us see this Control L. Let me clear the screen, and we have a new screen now. Now what happens? You see, look at the graph and try to understand. That's why I tell you that you should draw the graph also. Now here you understand, okay, since Anova is telling significant difference, this is significantly different from others. It is quite clear. But whether this company 2 is significantly different from company 1, because company 1 and company 3, their averages seems to be very close, but company 2 seems to be far away from company 1. Now whether this difference is statistically significant, and whether difference between company 2 and company 4 is statistically significant or not, that we want to know. Because once you are told that Anova has failed, null hypothesis has failed for Anova, that means you understand the averages are all not same. If it tells that average is same, then average is all not same. That is what is told by your Anova test. Now comes to my mind, who is then different? Are all of them different from each other? Or some of them are in one closer to each other, and some companies are doing very poorly? Amongst the poor, whether there is also significant difference? So this type of questions comes to our mind, and we need to solve this. It is somewhat like this, that there is sometimes some people suffer from a disease called as urine infection. Urine infection creates a lot of problems. Basically indication is there will be problems in urination, and there will be fever also along with urination. So all these issues are there when a person suffers from a urine infection. Now urine infection, you have to go for an urine culture. The corresponding test is urine culture. So what they will do? Result comes after 2-3 days, because they have to put the urine and see the growth of virus in it. Now if there is a growth of virus in urine, that means there is an urine infection, and then they will give an antibiotic. But if urine infection results in no virus, then the result test terminates there. But if there is a presence of virus, then they will do sensitivity analysis to find out that this virus is sensitive to which antibiotic and resistant to which antibiotic. Suppose there are 10 antibiotics, they will keep on testing, and they find that out of these 3 antibiotics, 2 antibiotics are resistant. That means these 2 antibiotics, if doctor prescribes those 2 antibiotics to the patient, the antibiotic will not work. They need to give a sensitive antibiotic, not a resistant antibiotic. But if there is no urine infection, if there is no virus in the urine, then the sensitivity analysis is not done. So this somewhat like that. If Anova is insignificant, that means all the averages are same. You don't have to go further. But if you see that yes, there is some amount of difference, some amount of deviation from the null hypothesis rejected, that means there is some amount of difference among the group means, and then you have to perform pairwise test, and which is done by a test called as Tuk test. So here in this case we have found that Tuk test is there. So we write the Tuk test as Tukey, Tuk, and H is D, honest significant difference H is D, and then our result is stored in ANOVA, this capital one. This is the name of the variable where I have stored the result of Anova, and then we press enter. Now when we press enter, we get the comparison. Now comparison, look at the corresponding p-value, and you will find out that comparison between company 1 and company 2, p-value more than 0.05. That means they are same. Company 3 and company 1, p-value more than 0.05. They are same. Company 4, company 1 more than 0.05 marginally. That means they are same also. There will be some difference between company 4 and company 1. But that difference is not very significant. Company 3, company 2 difference is insignificant. Company 4, company 2 difference is insignificant. But company 4 and company 3, this value is less than 0.05, and this is the only two companies which differ from each other. If we go back to the box plot, what is the solution here? Company 4 and company 3. So they are differing significantly. So this is company 4 and this is company 3. So company 4 and company 3, there is significant difference between the two. And what about company 1 and company 4? Let me check up. Company 1 and company 4, no, they are not statistically different. They are not statistically different. So this is the way in which we can go ahead with this. So we understand that here the two companies which differ significantly from each other is company 4 and company 3. So this is our conclusion, and this is how we perform the Tuk test. That is this is called as the Tuk test for significant difference of pairwise comparison. This is done only when the null hypothesis of Anova is rejected. So thank you for watching this video.